Hello folks, we are doing the exercise 3.1. This is our part 3 video and we are probably taking the question number 4 now. It's the question number 4, let's see what it reads. Question number 4 says, find the degree measure of the angle that is obtained at the center of the circle of radius 100 centimeters by an arc of length 22 centimeters. See, this is nothing new to us. Why? Because we have studied it in the 10th standard itself. We have studied the length of the arc, the area of the sector. When we were learning sector, we have learned all this. So it's just that thing. We have to just apply it there. What do they tell us? For the arc, okay, they have given us an arc. For the arc that is given. For the given arc, what all things are there? They say that the degree measure of the angle, you have to find the degree measure of the angle when the radius they give us as 100 centimeter and the length of the arc they say is 22 centimeter. The length of the arc, already arc is there, so of arc every time we need not write. So the length is this. We have to find the degree measure. Nothing new to us. Last year itself we learnt it, right? So this year only we have learnt radian. Last year we have learnt degree measure, and there we have learnt the formula also. What we learnt last year, we learned that we know that L equal to R theta. We have learnt it. It was like because now this is in terms of radians, so it is going to be by 180. This is what we learnt last year. So on the basis of this we will be solving the problem. So let us see now what all things are given to us. It is given to us that L is 22 by 180, R for us is 100, and theta is what we have to find. So let's switch everything on the other side and get the answer. Theta is 22 into 18 by pi into 10. This is coming to the denominator and this is going to the numerator, and pi we know from long ago that it is 22 upon 7. 22 will stay in the denominator, 7 goes to the numerator. So all this gets cut, and then you are having this 18 into 7 by 10. So you could do one thing is you can multiply and then place the decimal, so that way you will get the degree measure, or it's like your own wish. Otherwise, like, okay, 18 into 7, 7 8s are 56, that's 5 carry, 126 by 10. So you have 12.6 as your degree measure. So the angle is 12.6 degree. But suppose if you are not happy with the 0.6, then you will have to make the conversion. So 0.6 degree in minutes is going to be like, it's 1 degree is 60 minutes. That's a little bit of rough work. So 0.6 degree is going to be how much? So it's 0.6 into 60 minutes. So that way it is going to be like 6 6 are 36, and that 0 will come. So like that you have 36 minutes. So actually you can have the angle now. Therefore theta equal to 12 degree 36 minutes. That's how you get the answer. Yeah, that's how we get the answer over here. Yeah, so that is about the degree measure of the given arc. Now let's move to the next question. In a circle of diameter 40, the length of the chord is 20. Find the length of the minor arc. Okay, so it's a circle of diameter 40 where we have like, it's a circle, they say, whose diameter is 40. They say that there is an arc whose length is 20 centimeter. Now if the diameter is 40, it's very clear to us that the radius is 20. So this is the picture. They say that if this is the case, they ask us to find out the length of the minor arc, length of the arc. L you have to find. Anything, whether it is in degree or radians or something, they specified? No, they haven't specified. So yeah, so we'll do it in, let's say, in whatever convenient way. So maybe like, it depends. Here diameter is 40, so therefore the radius is going to be 40 by 2, that's 20 centimeters. Then suppose say the given case is as shown in the figure, we observe that triangle OAB is equilateral triangle. Don't we observe it? Yes, we observe it. Why? Because it was given to us that this chord is 20 centimeters and they have told us that the diameter is 40, so the radius becomes 20. Like that, when you take up the triangle becomes an equilateral triangle. And equilateral triangle is a huge data. Why? Because it gives us this angle. And we know what is in an equilateral triangle is also equiangular, where every angle is going to be 60 degree, and in particular this angle is also going to be 60 degree. So we can have here or now we have theta to be equal to 60 degree, or if you want it in radians, it is 60 into pi by 180. So like that, it is going to be pi by 3 radians. So it depends. In whatever way you want to calculate, you can calculate the angle and find out the answer. So you have got theta now. They have asked us to find the length of the arc. So in order to find the length of the arc, so length of the required arc is going to be r theta whenever it is in radians. So r for us is 20 and theta for us is pi by 3. So like that, your length of the arc is 20 pi by 3. 20 pi by 3. So that is the length of the arc. So this is how we go across doing this problem. Wherever the radian is given, wherever the angle is given, we have taken the angle and we've got the answer. So this is the length of the required arc. We can quickly move to the 6th question and see what it says. If in two circles arcs of the same length subtends angles 60 degree and 75 degree at the center, find the ratio of the radii. Slight twist from the normal question. They say that there are two circles. Yeah, we can have one jumbo circle and one, something like that. This arc is the same, but they subtend different angles. This length of the arc will be the same, but in one case they will subtend 60 degree and in the other case it will subtend 75 degree. See, there is with center O and this is with center C. The length of the arc is the same, and they ask us to find out the ratio of their radii. The radii's ratio, whatever it is that, see, in such type of questions, your introduction should be perfect, like everything that is there over here, they will have suffix 1. Everything that is there over there, that will have suffix 2. So here R1, theta 1, L1. There R2, theta 2, L2. That way those things should be clear, and then once you have made those things clear, then we can get across doing our solving. So first let the circles with centers O and C be given. Okay, then we can say let theta 1, L1, R1 be the angle at the center, length of the arc, and radius for circle with center O, and theta 2, L2, R2 be that for the circle with center C. So we have introduced. Now everything is very easy, right? See, what happens is here we will have L1 is R1 theta 1. We know it long back. We have learnt the formula, and L2 is R2 theta 2. But L1 is equal to L2 because they have told that both the lengths are equal, they have told us. So therefore L1 equal to L2 means you have R1 theta 1 becoming equal to R2 theta 2. Question is to find out the ratio between R1 and R2. So that we will retain on one side. R1 and R2 we can have it on one side. Theta 2 and theta 1 we can make it on one side, and these angles we have it. See, this holds only for radians. So therefore we can get it converted into radians. This is theta 2 is 75 into radians, it's pi by 180, again 60 pi by 180, no use, it gets cancelled only, so no problem. Now 75 and 60 is there in the table of 15 if we know it. If we don't know it, first by table of 5, then by table of 3 we can cut and get the answer. 15 5s are 15 4s are, so it comes to 5 by 4. They have asked us in the question what is the ratio. So the required ratio is 5:4. The required ratio comes up to 5:4. This is how we go about doing this problem. There's one more problem left in the exercise that we take it up in the next video. Thank you.